Okay, so we're going to learn about dimension of physical quantities. Okay, don't be stressed. This is still the basic of physics in STPM, not yet the hardest part. Okay, so dimension are used. Okay, dimension are used to refer to the physical nature of quantity and the type of unit used to specify it. Okay, there are 7 base quantity. For STPM, there are 7. SPM, you have 5. Okay, with their respective units and dimension are shown below. So you can see that if quantity, that is length, unit, you use the letter M, small m, but the dimension you see on the right side, everyone can see, right, the table. Can everyone see the table?
Yes. Yes.
Okay.
Yes.
I put out chat here. Okay, so the dimension for length is capital L. Okay, and every letter for dimension is a capital letter. So the mass unit will be kilogram and dimension is big M. Time unit S, time will be T, big T. Okay, so this one T, because later on you see that you're dealing with temperature. Okay, some people, some students will be confused. Either it's a T for time or either it's T for temperature. Okay, so time is big capital T, temperature. Oh, sorry, the big time T for time. It's not temperature. Electric current A, also A dimension, big capital A. Thermodynamic temperature means the temperature unit is Kelvin, as you know, Kelvin. Dimension will be a theta, symbol of theta, amount of substance N, dimension N, and luminous intensity should be I. You have to memorize this dimension for all the quantities, 7 quantities. You have to memorize. Okay. So dimension analysis is used to check whether mathematical relation physical quantities have consistency in terms of their dimension. Okay. So why does we have dimension? Okay, you see, why does we have dimension? A physically correct equation. Now we're talking about equation. The maths must have the same dimension on unit both left, right, or both on the left, right hand side, RHS, and the left hand side, LHS of the equation. It means that if you have an equation, left hand side must be equal to the dimension of right hand side. If the dimension are wrong, I mean the left and the right dimension are different, so the equation is wrong. Okay, so let's say we have here an example. Suppose a car starts from rest and accelerates to a speed of v in the time t, and the distance x traveled by the car is assumed to be either. So we have, let's say we have two equation. X equals to half vt squared. Okay, half vt squared, and one more, or we have x equals to 1 over 2 vt. Okay, so okay, let's say who choose on the left side, 1 over 2 vt is a correct equation. Okay, raise up your hands, or you can put chat as me, write your name, me. I need interaction from you. Okay, this is not a YouTube video. Put on the chat if you think the left hand side, left equation is a correct equation. Faster. Put on the chat. Left. Left side. Who says left side? The left equation on the left is the right one. I want you have to write on here, right? Then you this one. This one is the one you choose as the correct. Who says on left side, left equation is the correct one? Nobody. Okay. Who says the right one is the correct equation?
Yeah, sir, we think first.
Okay. Okay. Xander says on the right. Rainin also says on the right. Who says left? Okay, I'm not going to scold you if you got wrong, because this you haven't learned yet. Just a guess of luck. Okay, right. Nicholas says right. Kugan says right. Okay, so let's see. Okay, the monument of truth. Okay, so where's my mouse? Okay, so checking the dimension of both sides of the equation. So we have to check, is it the x or the dimension of the x over here? Take another color. Is this x dimension, like the dimension, is equals the whole thing over here, the dimension. Same thing as this one. This dimension is same as the whole thing of this dimension. Okay. So we want to check that. Okay, we have to check. So take this one, I mean the left hand side, left equation. X equals 1 over 2 vt squared. Okay, and one more, 1 over 2 vt without the t squared. The difference is only t squared, right? Okay, so the dimension, remember the dimension, we have to memorize all these letters over here: L, M, T, A, theta, N, and I. Okay, so we substitute everything. So you see the x over here. Okay, x is a length. Correct, right? This is a length. Okay, my writing is not good when using this vacuum. Length x. So length over here is dimension will be substitute by L. So you can see that x over here is L. This bracket, it means that the dimension. Okay, the dimension of x. So they have the bracket over here. Can see that? Okay. So the dimension of x is L. So 1 over 2 is constant. Okay, so we can ignore a constant. 1 over 2 is constant. So v over here, okay, v equals to the length divided by time, or we can say that it is a dimension of length L divided by t time. Okay, L over t. So that's why we have L over t on the second part, second term. T squared, because t is squared, so t dimension of t squared is t squared. Okay. At this point, do you understood any question until this
No
point?
question, sir.
No question.
Understood, sir.
So everyone clear, huh? Right? Uh, who is still not in the class? 1, 2, 3, 4, 5, 6, 7, 8. Huh? 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, everyone here, right? Monitors, can you check? Is everyone here already?
6 1, yes.
6
Science 2 also, yes.
times 2 also. Okay. So you already you have a clear how to convert into dimension from equation. Okay, next part is, okay, next part I want to clear up this thing. Clear the, okay. Now, after we convert into dimension, next is we can cancel out the t. So this is t squared divided by t. So you have L equals to LT. So this is wrong. This is wrong because why? Anyone, can you answer me why this is wrong?
Extra T.
Yes, we have extra key. Okay, we have extra t over here. Okay, it should be L equals to L. Dimension of L equals to dimension of L. Okay, let's check this one. So L equals to L over T times T. So we can cancel this part. And we have L equals to L. So for the right hand side equation, dimension on the left of the equal sign matches on the right side. So the relation is dimensionally correct. The equation is homogeneous and it says to dimensionally consistent. So if you have this kind of equation, question, you cannot end like this. You cannot n, of course, if this is correct, you cannot n like L equals to L times T or L equals to L. Okay, you cannot n like that. You have to write on the bottom. You have to write on bottom dimensionally inconsistent. Okay, or this one dimensionally consistent. Okay, this is how you answer this question. You cannot end with an equation, but you have to write down either is dimensionally inconsistent or dimensionally consistent. Okay, are we clear? Are we clear or not? Okay, so this is how you answer a dimension question. Okay. Yang modulus. Okay. So this one I will keep for the next slide. Okay. Where's my mouse? Okay. Okay. Next is we want to try. Okay. Now we want to try the dimension of acceleration. Find the dimension of acceleration and its SI unit. Okay. So this is just for example. Dimension acceleration is the formula of acceleration is
V over T.
V over T. Okay, we can change over velocity over change of time. So we can say that this is V. So dimension of V is what?
LT negative 1.
LT.
L
LT negative 2.
L over T, yeah, right. So L over T. So we can put here L over T and big one over here over T.
T.
Okay, so we have L T. What is it? L T
Negative 2.
negative 2. Okay, so dimension of acceleration is LT negative 2. Okay, as a unit, because this is a L. L stands for length, and unit for length is meter, and T is second. So a second negative 2. Okay, so this is actually you know what is the SI unit for acceleration just to get what is the dimension of the acceleration. Okay, find the dimension of pressure and its SI unit. So pressure equals to everyone.
Force
Pressure
over
equals to
area.
force over area. 1, 2, 3, 4, 5, 6, 7, 8. Somebody left. Who's left? 1, 2. Left the class. No. Come back.
Come back. Just come back.
Okay. So pressure equals to force over area. Okay. And dimension of force. Force equals to
Mass times acceleration.
mass times acceleration. Correct. Mass times acceleration. So mass is the big M. Acceleration just now we just got the acceleration is LT negative 2. Right. So it is M. It's capital letter, right? So LT negative 2 divided by area. Area is
Length. L.
area is L times L. This is L squared. So it's L squared. Okay. So what happened here? What is the answer? M. How about the L? What happened to the L?
L negative 1.
L negative 1. T negative
Negative 2.
2. Okay, so that will be the dimension of pressure. As a unit, this is M. Sorry, M is mass kilogram. L is length meter per meter. T is uh time. So
Time.
second per second squared. So kg m1 m power of negative 1 s power of negative 2 of second squared per meter per second squared. Okay. Are you clear, everyone? 1, 2, 3, 4, 5.
Yes, sir.
1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So dimensional homogeneity, this one we already done. We want to check either dimensionally consistent or dimensionally inconsistent. Okay, so S equals to UT plus 1 over 2 AT squared. So S equals to UT plus 1 over 2 AT squared. Okay, I'm going to call somebody here. Wei Hen. Wei Hen, unmute.
Yes.
Okay, so what is the dimension of S?
L.
L.
Mm,
Dimension of U?
LT negative 1.
T negative 1. And then
Yeah. T is T.
T.
So cancel. And plus F. A is just now LT negative 2.
and then
T, T square.
T squared. Okay, you should put the bracket, but this one just for learning. I make it speed up. Okay, you should put the bracket. So end up with Wei Hen.
L plus L. 2L.
No, this one
L
first.
plus
This one will be
L. Yeah.
L. Okay, plus.
Plus L. Yeah. So
Okay.
2L.
So this is a correct, or we call as a homogeneity consistent. Okay. Dimensionally consistent because this is L. This is also L and this is also L. You don't need to plus both of the L. But if you see that this is L equals this is L plus T, this is wrong. Okay. It should be everything. Wait, this is what we call term, right? Term. Okay, this is also one term. All the term must be equals to the dimension of the equation title. This is we call as equation title. So equation title over here, all the term must be dimension of the all the term must be equals to the equation title. Okay. Okay. Narin, representative of ABC. Narin, are you there?
Yes, sir.
Okay. So V equals to U plus 2S.
Uh,
V first.
V L over T, sir.
V
V L over T.
L over T or L T minus 1. Right.
Ah,
Okay. U
yes, yes. U wait, sir. Don't know, sir.
What is U? What is U actually? What your U stands for?
U for
What is a U for in physics?
forgotten, sir.
Forgot. U
Forgot.
stands for initial.
Initial mass.
What?
Initial
Initial
velocity.
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 This one V.
Right.
V stands for.
Velocity.
This is initial. This one stands for V.
V.
V stands for. And you have initial.
Velocity.
You have.
Final
Yes. Final
velocity.
velocity. So this and V and U is actually. It's actually what? V and U is. Yes, it's a velocity. Both of them are velocity.
Velocity.
So U is
U.
what's the dimension for U?
L.
L.
No.
L.
Yes. Yes.
Yes.
LT.
LT.
-2.
-2. Narin. V
So,
and U. You see, V and U are both velocity. So can you
yes.
see this one? The dimension of V, you are correct. How about this one? Should they be same or what?
Same, right?
Yeah, it is same.
Same.
Because both of them are velocity.
Velocity.
Okay, plus. Now, this stands for A.
A for speed. Speed, right, sir?
No.
A
A stands for what?
So last time I studied in BM, so
Okay. Okay, tell me VM. I can do both of the language. Okay, A stands for?
A stands for acceleration. Acceleration.
Okay, now you're talking English. Okay, acceleration. Okay, now what will be the dimension of acceleration? In previous slide, I already teach you what is acceleration. I already show you the acceleration dimension. Okay,
LT
L.
-2. So
LT
-2.
-2.
2.
Okay, correct. So S.
Sasaran, sir.
Sasaran. Okay. So sasaran is what? What is a sasaran? It's a measure of
Measure.
jarak. Okay. So
Jarak.
on this, you see the table over here. Can see the table
Yes.
over here. Which one is
L.
yeah, L. Okay. Can you work out this all of this one? What happened? What will be happening to all this one? L.
L plus L.
L. For this one is this one first. This term first. L.
L T.
LT.
-1
-1. Okay. Plus
plus L
L.
T.
This L and this L are multiplied. Okay. So what happened to this L? L
L square.
squared
T -2.
T -2.
2.
Okay. So I'm asking you, is this equation dimensionally consistent or dimensionally inconsistent?
Consistent.
Consistent, it means that it is correct, or dimensionally inconsistent, it means that it is wrong.
I thought inconsistent, sir.
What you say is consistent?
Um, don't know how to say.
Okay, actually you are wrong. The first term, you can see here, the first term over here is correct because it's equal to the equation title. But this one, the second term are wrong. You can see this is L squared and this is
Square.
T power of over T squared. So it is not same as the equation title, the dimension of equation title. So this is dimensionally, what I call dimensionally? Okay,
Inconsistent.
inconsistent. Okay, inconsistent. Okay. Next time, remember, Marin.
Okay, sir.
Now,
Okay, sir.
STPM, although the paper is in BM, but you have to learn English now. Okay.
Okay, sir.
Okay. Okay. Next exercise. The power of overcome external resistance when the vehicle is driving at a speed of V is given by the expression P equals to power equals to AV plus BV squared, and the A and B are constant. Reduce the unit for A and B in terms of SI unit. So P equals to AV plus BV squared. The challenge is to find, it is the thing is he want to find what is as the dimension for A and what is the dimension for B. Okay. The trick is you know that this term 1 and this term 2 will be equals to this term from equation title. So term 1 and term 2, the dimension will be equals to the P. Okay, so we can find what is the dimension of A. Okay, now I'm calling, who's the Sikledang girl? Forgot her name. Wen Yan ah?
Yeah,
Is
to,
it? Okay,
yes.
now tell me what is dimension of power P?
Word over time.
Okay, so power is work over time. Okay, can you get the work? Work equals to?
Mass
Huh? Work equals to?
times m.
Work.
Work is equal to
Work equals to?
force times displacement.
Force by displacement. Okay, we find the dimension of Fs first.
M.
What is the F?
M.
MA.
M.
Okay, so
M.
M times with A is what? Acceleration.
Acceleration.
So,
So is LT negative 2.
okay, LT negative 2. So here we have M LT negative 2. S is
L.
L. So end up with M
L square
L squared
T
T
negative 2.
negative 2. Okay, correct. So this one, wait, I erase this thing. Okay, nice. Right. Okay, so M L2 negative T negative 2 over for
T.
power T. End up with M
ML square
hmm,
T negative 3.
3. Okay. Now you found what is the dimension for P. Because I put over here M L squared T negative 3. Okay. And then we have A. A I'll put over here. This is A. What is dimension for V, velocity?
LT -1.
LT -1 plus B.
B
Okay, V. This is a velocity squared. So
L square LT -1 square.
L squared
L
T
negative
-2.
square.
Correct. Is it correct?
Yes.
Okay. Now, okay, we want to do the first term over here first. Okay, I'm going to erase this one. Okay. Can you see the on the screen? Or it's too small? Can you see or not on the screen, or it's too small? So M L squared T -3 equals to A L T -1. So A equals to what? A equals to M L squared T -3 divided by L T -1. Okay, Yan, what will be the answer?
Yes.
A is
M
M
L
M
L
L
T
T
-2.
-2. Okay, now B. For B, it will be B will be M L squared T -3 divided by L squared T -2. So B will be
M
M
T
T
-1.
-1. Okay, so you're correct. So what will be the SI unit for A? SI unit for A? SI unit is SI unit for A is
kg
kg, correct?
M
Meter
S
S
meter -2.
-2. For B,
Force.
force.
For
B
B
kg
is kg.
kg. And then
S -1.
S -1. Okay, correct. Okay, good job. So this will be the dimension for A and dimension for B. Any question? Or you want to jot down this working?
Cikgu,
Yeah, good.
sir, can
Yeah.
repeat how search P into the P into the P into the dimensional quantity?
Can't hear you. What is it, good? How to?
Can can sir repeat how sir change the P into the dimension?
B into dimension?
P into dimension.
Oh, power.
M
Oh, power.
power.
Okay.
Yeah.
Where I don't have any more place. Okay. Where can where can I put my? Okay, can you have you? Let's see. If I can erase this part. This one you have done, right? You have known what is happening here, right? So I can erase this part. Okay. So P power. Okay, power is work over time. Okay, this is very basic equation. Work over time. Work is force times with displacement over time. Okay, now we want to get to into detail of the F. What is F? F equals to M A S over T. Right, F equals to M A. Okay, so now we convert everything here into dimension. M mass is M. A acceleration is LT negative 2. S is L and T is T. Okay, Google.
Okay, sir.
Can you see on the screen there?
Yeah, can.
Okay, so you end up if you do the working, you end up with ML squared T negative 3.
Yeah, okay.
Okay, so I'm going to stop at this point. Okay, I'll put a module for you because you don't have any textbook yet. Okay, and then some exercise in the module. Okay, but we see you on. Oh, today is the last day in this week. Okay, see you on next week. But we're going to give you some exercise before next week, Monday. Okay, so before I end the class, any question? Everyone?
No, sir.
No, sir.
Thank you.
No?
Thank you.
Okay.
Okay.
I hope you revise back what is acceleration, what is this displacement, what is power, everything. By at this point, you should have memorized all these things. Okay, what is the power, what is the work, what is time, everything. Okay, I'm not going to repeat what you have learned in Form 4 and Form 5. Okay, because later on it will be harder and harder and harder. Okay, so see you next week. Bye bye.
Thank you, teacher.
Okay.
Thank you, teacher.
Anyone
Thank you,
absent
sir.
today?
Thank you, sir.
Thank you,
No,
sir.
sir.
Anyone absent today? Monitor?
No, sir.
No.
No one absent, sir.
No one absent. Okay. Okay.